Good morning, good afternoon, good evening to our guests from around the world, and welcome to this session called NAVDAT and Modernizing GMDSS. This is part of a series of webinars that we'll be hosting through the coming year, and I thank you for attending. I think you'll find this is a very informative session. I'm going to introduce our guests and walk you through the agenda. And if we could move to the next slide, please. And so today joining us, we have Hermann ZENSEN, Sales and Marketing for Kenta, and very pleased and honored to have joining us today Jean-Charles CORNILLOU, and Jean-Charles also known as Captain Jean-Charles, and he is the French expert in radio communications in IMO discussions. And I am the head of marketing for NAVDAT and product strategy. Today's agenda will be fairly packed. We'll do a quick introduction, thanks to Hermann. We'll walk through NAVDAT's history, the modernization of GMDSS, the advantages and field trials, broadcast modes and broadcast chain, all related to NAVDAT. And we'll take some time for questions and answers. If we can move to the next slide, I'll let you know how to do questions within the webinar mode. So next slide, please. And so you'll find on your screen the GoToWebinar panel. If it's minimized, there's an orange button that you can click that will reveal the question panel. You can enter your questions, and through the webinar, and certainly at the end of the webinar, we'll take some time to answer your questions. And with that, I'll hand it over to Hermann ZENSEN. Hermann, welcome.
Yes, next slide, please. Thank you very much. Yes, good morning, good evening, and to everybody. I'm Hermann ZENSEN. I'm in charge for sales and marketing for Kenta. And I will just present you 2 or 3 slides, just telling you who we are and where we are, okay? So you can see on this slide, you can see, yes, we have 2 companies, Kenta and Nortel, and Kenta Technologies owned 100% by Nortel, okay? So we are in Europe, we are based in France, as you can see on the right side of the slide, and Nortel is based in Canada, the headquarters in Canada, in Halifax, and there are 2 facilities. One is their headquarters, and the other one is in the United States, in Maine, where they have the factory typically producing NAVTEX transmitters. And on the right side, you can see then the European part, the French part. So also we have 2 facilities, one in Rennes and one in Quimper. So it's more like 2 workshops. So we produce in Quimper, we will produce then all the other products that we have for Kenta GMDSS product line. Okay, transceivers, receivers, we'll explain this a little bit later. And yes, so you can see we have one company, let's say one company is which is Nortel, and yes, 2 continents in Europe and in the United States. And we are both passionate about maritime communication. By the way, if Nortel, if you have the name Nortel, it comes from nautical communications. So Nortel started in the maritime field and then came later to the broadcast, where it's very well known for its AM and FM transmitters. We are member of Kenta Technologies. We are member of 2 organizations. One is CIRM and the other one is IALA. I think IALA most of you will know. But CEREMA, just for a short explanation, this is an association of industrial companies. And CEREMA is a little bit the interface for the industry to the International Maritime Organization, to IMO. Okay, so we are a member of this. You know, IMO, the states are presenting at IMO, so it's not industrial companies. The states have the right to vote, and the industrial companies, we can only give a kind of advice and consulting, and this, the interface for this is CRIM, so it's an important organization. And then you can slow the next slide. Just some words about Nortel. So Nortel is 54 years old now, more than 200 people working for Nortel. As I told you, we are a maritime business, but also in in broadcast business. So it's so we have lots and lots of deployments, 20,000 all over the world. And for the NAVTEX part, Nortel and Kenta together, we are the largest provider in the world. Okay, so Kenta Technologies is a little bit younger than Nortel, but it's not a startup either. We have been created in 1990 as a Furuno spin-off. And yes, we come from maritime communications right from the beginning. And the GMDSS solution is, we have this since 2013. Okay, so it's not so old. Okay, more than 10 years now. And it's a complete solution. So we develop all our hardware and software internally. And we have key competences around, yes, like IP that we had discussed in the last webinar, digital transmission, digital modulation, okay, radio communications in all types of frequencies, medium wave, high HF, VHF. We have good experience on frequencies less than 30 megahertz. Is our strong point with lots of site surveys we did and lots of site installations we did. And yes, we have this expertise in software-defined radio. All our products are based on software-defined radio. And this makes it, by the way, way easier for NAVDAT to be developed. You can show me the next slide. Yeah, here you can see this is, yeah, we are in the world of terrestrial GMDSS. Just to distinguish this from, we are not in satellite, okay? So we think the terrestrial GMDSS has a great future, and it's still very, very important to have services that don't depend completely on satellite. And as you can see with these services on different frequencies and with different, you know, on MFHF, on VHF, and with different services like NAVTEX, DSC, voice, you can cover all areas that are defined in the SOLAS convention, so A1, A2, A3, and A4 area, okay? So this is for the introduction, and I hand over now to Jean-Charles.
Thank you, Hermann. Good morning, everybody. I'm speaking from France, and my intention is to show you some basic information about the NAVDAT. But for that, it is important to make some perspective in the history of radio communication. Because if you are taking into account the history of shipping, in the antiques, at that time, the ships were a real autonomous means of transport because the crew was totally isolated from land and has to rely on its own resource and capacity to face danger of navigation. But that was only in 1900 that the well-known Marconi has introduced a link between the ship and the shore. And that is very important for Marconi Wireless Telegraph Company had the monopoly at the beginning of the 20th century of radio communication, using ship station to relay messages from one continent to another. And for sure, the disaster of the Titanic in 1912 was highlighting the importance of radio communication for the two Marconi operators on board has been known to transmit one of the very first SOS through radio telegraphy, and in that helps to reduce the number of casualties with the rescue of people saved to this radio message. But nowadays, so you see it's a very short history, we still have the last safety measure is still search and rescue, SAR. And the International Convention on Maritime Search and Rescue has been adopted in 1979. And Resolution 6 of this international convention proposed to develop a global maritime distress and safety system. So in order to first support search and rescue services in the world. So GMDSS was prepared at International Telecommunication Union in Geneva, and this is the purpose to be used by all ships, because whatever the size, as soon as the ship got a radio station, they are able to transmit any kind of message, and first a distress message. Then IMO decided to implement GMDSS on the 1st February 1999 for all SOLAS ships. Let's see now what's happened the 10 last years at the IMO, at the International Maritime Organization, with the modernization of GMDSS and e-navigation. Again, a very short story, because I will summarize in two steps 12 years of works. The modernization started in 2009 at the Maritime Safety Committee of the IMO. We start to establish a scoping exercise to see the need for review and procedure of GMDSS. And for that purpose, a very deep core expertise meeting was used, is the IMO ITU expert group meeting was the start of reviewing the GMDSS with the help of a corresponding group for the modernization of GMDSS. And more than 12 years later, in April 2022, the Maritime Safety Committee adopted a relevant draft amendment to SOLAS Convention, in particular Chapter 4 on radio communication, and many other texts, of course. That is the amount of document text has been reviewed, or an average of 40 text resolution circular has been impacted, and all that for an entry into force on the 1st January 2024. That is to say, after Christmas. So you have to be aware that some change occur in the document international view of GMDSS. But basically, the functional requirements do not change, because these functional requirements are adapted to any format of communication, telex, voice, or even digital, and any radio communication system, terrestrial or satellite. And so it is very important to understand that GMDSS is a combination of radio communication system, and they are all complementary systems. We should not oppose terrestrial to satellite. These are all necessary for a ship, and a basic principle which is still maintained is to have two independent means of transmission of a distress alert. So for sure, if we are putting all our eggs in the same basket, as we say in France, if you are sending all the distress through satellite and there is any problem with satellite, so we need to look for a terrestrial system. So these are basic points, but be aware that in the new text of the chapter 4, we have prepared new technology. This has to be read between the lines, because we have removed, for instance, the term NAVDAT or enhanced group call. We just say that ships needs to have proper MSI receiver or receivers in the area they are navigating. So full stop. So that means we have prepared the future, and in a way, NAVDAT is prepared to be ready in GMDSS that way, because what we accepted at the IMO is to refer to a circular that can be updated easier than a convention, because it took 4 years to change a full text of a convention as a minimum, but a circular can be changed within a meeting and be in force for the next year. So this is much more easier to introduce. And that is the kind of things that has been introduced, which are not obvious when you read the text, but you have to be aware. But now, in line with the implementation of the e-navigation, that is another discussion introduced at the IMO many years ago, the idea is to introduce now in radio communication digital communications. The gap analysis of e-navigation identified the need to present information into graphical format. This is not something very new. you are aware that there are still in the world 30 HF stations broadcasting facsimiles. So you know this device with a special paper printing graphical information for seafarer. And this is a very old technology, but still in force. This is not in the GMDSS, but this is recommended by the World Meteorological Organization to receive weather charts, for instance. But the idea is to shift to your computer, and in order to receive digital information for a much more easy way to handle information. On the same time, at the ITU, they adopted different texts related to NAVDAT, and the very first one adopted in 2011 was on the use of the so-called historical 500 kilohertz frequency use for the first SOS of the Titanic, and has been reused for the maritime world for transmitting, broadcasting digital information. And later in 2014, ITU adopted the recommendation on NAVDAT HF, and in 2018, NAVDAT guidelines. And more important, in November 2019, the World Radio Conference confirmed the use of all frequency bands for NAVDAT, from 500 kilohertz to the other HF band, 4, 6, 8, 12, and etc. They are now stick in the radio regulation in the HF and MF frequency. Be aware that in January 2020, just before the pandemic of COVID, China and France presented at the Subcommittee on Navigation, Communication, and Search and Rescue some test measurement on NAVDAT under real condition. And with full support of a member of the NCSR, in order to introduce a new output for works at the IMO. But it is the reason that we lost 1 year because of the pandemic, because as soon as the conclusion of the NCSR, China and France prepare a document to be submitted for the MSC to accept the work to be carried on at the IMO. So this is very procedural, but that's why we spent 1 year extra because of this pandemic. But in May 2001, the MSC accept to work on the performance standard for NAVDAT receiver. And in May this year, at the subcommittee in charge of this technical question, navigation, communication, and search and rescue, there was a common proposal submitted by France, China, and Ireland, the all three signatories of the submission, to develop performance standard for NAVDAT receiver, and also to propose NAVDAT service area. And we also go further by proposing also a NAVDAT manual. In a way, we propose how to broadcast info on NAVDAT and how to receive info by NAVDAT. So these documents are public, and we are under the work to update it. So the idea to keep in mind with the GMDSS is to broadcast the appropriate information in the appropriate area at the appropriate time and with the appropriate communication system. So in a way, you have in your screen the two main area for broadcasting information to seafarer. So NAVAREA, METAERA are dedicated by IMO, ISO, and WMO for the broadcast of navigational warning and meteorological information through satellite. So you have this area, NAVAREA and METAERA. They are the same region, geographical region, and divided into the world, and these are the responsibility of only 18 countries. But within this NAV area and meta area, they are the coastal area, an average of 200 nautical miles, and there is a unique example of coverage of NAV area by only NAVTEX is in the Baltic Sea. I was just this morning in liaison with the NAV area coordinator 3 in Spain, and we agree that technically it is possible to cover only by NAVTEX all Mediterranean, including the Black Sea, who is in charge of the coordination. So you see, it is important to balance the different appropriate communication, because if you broadcast on NAVTEX, no need to broadcast information on satellite. This is more and more important as we need to be efficient for the hydrographic service and meteorological service. For we are looking to digital information, and on satellite, digital means a lot of band to pass EV files. So that means it costs money to be broadcast in a way. And on the other side, you don't need to inform ship in the middle of the ocean about some lighthouse problem on the coast. So this is something that is to be balanced, and that's why there is the organization of the Worldwide Navigation Warning Service and the equivalent at the Weather Organization with the Worldwide Met Information Warning Service. Let's see to the advantages of NAVDAT. Basically, with the process to go to digital information, an information provider, such an hydrographic office, can provide directly to the NAVDAT station a S124 message. The S124 message is a format of navigational warning that can be directly adapted to electronic chart. So this is quite interesting, because on board the ship, the NAVDAT receiver can receive it directly, but not only receive, but with the integrated communication system, can shift the information directly to the EGDIS. So this is the motion of so-called e-navigation, but the impelling modernization of navigation has been introduced by ISO with electronic charts. And so there are some consistency to think about this way to get smooth information and easy access to seafarer. But be aware that a NAVDAT station can broadcast also NAVTEX. Of course, not the reverse. It is easier with a new system to make an older one. But you see the interest now for hydrographic office that are now already in the world with digital information. They have to translate into telex in order the information be transmitted through NAVTEX. And then receive on board, the seafarer has to translate the information, whether on his paper chart or on his electronic charts. So that is the way we have to think about it, but the interest also to think about the future of new NAVTEX station to be ready for broadcasting NAVDAT, because I know, just have a look to the number of NAVTEX stations in the world that need to be renewed, and to think about the future in the translation that will be the process to be used for NAVDAT ready as soon it will be possible. So let's have a look to the presentation made by France and China. At the IMO, we made some test measurements, both sides of the continent of Europe and Asia. The first one was made in 4 megahertz test in Atlantic, in the western approach from the island of Ocean, with a basic MF transmitter of MRCC CEREMA, also well known as a VTS, as ocean traffic at the entrance of the channel. And we had made some measurement of reception of message on fishing vessels quite far away from the island, up to more than 300 nautical miles. China did the same, but on 500 kilohertz, with transiting merchant ship from north to south, and also going from Shanghai station, where is test NAVDAT station, but also from Shanghai ship going to Japan. So they are still continuing to transmit and enhancing the system. So example of digital file transmitted to fishing vessel in France are on the screen. So it was quite interesting because we doesn't want to disturb the fishing vessels. They were in deep summer campaign of tuna. So you can imagine, as it is the case everywhere in the world, fishermen are fishing first and not looking to their NAVTEX. But the receiver on the fishing vessel were connected to a laptop, and they were very surprised to see some colorful picture on the laptop arriving suddenly when transmitting. So this was a quite enthusiastic signal from the fishermen that they were very happy and pleased to see such a way to receive weather information on the case. And the idea also to use a fishing vessel was the quality of electromagnetic environment of a fishing vessel is very bad. And so it demonstrates the reception, whether the type of ship. So the idea was that if a fishing vessel can receive it, it will be easier on a merchant ship where the antenna are more dissociated and there are much more room to place the proper antenna at the right place. Broadcasting modes of NAVDAT. So we had here a real new difference with the NAVTEX because, of course, the NAVDAT is performing a general broadcast to all ships, as it is the case with NAVTEX. But NAVDAT can have also a selective broadcast to a group of ships or a specific sea area. We can send also a dedicated message to one ship. So obviously, the general broadcast is in GMDSS, the most common use for broadcasting navigational warning or weather information. But imagine also GMDSS is also for distress communication. And in distress communication, you have search and rescue communication. You can imagine a general broadcast to relay a distress for ship to make a MIDI relay. And then the MRCC can request a selective broadcast to all ships involved in the search and rescue area with the transmission of a search pattern that can be quickly introduced into the EGDIS for all ships involved in the search. And then the MRCC can send a dedicated message to the on-scene coordinator in charge to coordinate the operation on scene of the search and rescue operation. So this is an example. Because we are in data, there is a possibility to encrypting sensitive files through the broadcasting. So NAVDAT can be used and has been prepared at ITU for also security information. That can be used also for fishing information for the quota, etc. Level, and some type of message has been prepared in the ITU recommendation for overuse than GMDSS. Another transmitting mode of NAVDAT is the single frequency mode. That means if you have the network of different NAVDAT stations, you can broadcast simultaneously a message, for instance, a tsunami alarm that can be broadcast, and you are not limited to the time slot in this case, because you are transmitting the same time with this single frequency network. Of course, to be efficient, you need to use a common server monitoring and controlling the different stations of the network. Otherwise, this will be some time shift difference. But I have to remind that all GMDSS infrastructure established by government could be established in common. This is all the time reminded at the IMO. This is in the SOLAS Convention, because the system is global. Starting from a simple VHF coast radio station or a NAVDAT, NAVTEX station, you can share it, because we need to coordinate all these stations. And so in the end, this is for the common use of a global search and rescue plan and global system we need. So that's why some economy can be foreseen just by looking to the proper place of the NAVDAT station, even the NAVTEX station, to be shared by different countries and covering the proper area. So if we may compare NAVTEX to NAVDAT, because there are two different technologies. NAVTEX is limited to telex, but shall I remember the flow of data is 50 bits per second. I repeat, 50 bits per second. This is the equivalent cadency of transmission of Marconi transmitter. So you see that the history is not so far away, but of course, modernization is going step by step, because before the NAVTEX, there was operator on board the ship that receive information, maritime safety information, directly on radio telegraphy. They have to translate it into readings, and the NAVTEX now can do it automatically. So the way forward now with NAVDAT is to broadcast digital information, whatever the size. If the format of ISO is S100, so anyway, it is supported by any kind of digital format. So the question is a question of flow and volume. So you see, if we may compare on a 10 minutes broadcast, the capacity of broadcast is 1,500 kilobytes of data that can be transferred in 10 minutes with an average flow of 20 kilobits per second. I insist, this is an average flow. This is not so simple as a NAVTEX, because with NAVDAT, you can set different parameters, the QAM, the error code, and so you can adapt your transmission with the information. For instance, a Mayday relay, which is a distress communication, can be transmitted very quickly, because it doesn't take a lot of volume. But if you have to transmit with a chart, this needs much more voluminous, and you can set it automatically depending from your files to be transmitted. So I give you the hand back to you, Hermann, for the following.
Thank you very much, Jean-Charles, for these precious insights. Yes, I will talk then a little bit more about how the system can be realized from a manufacturer point of view. Okay, yeah, thank you. So this slide, I took just a slide from the standards that Jean-Charles has mentioned before. Thank you. It's a 2010 standard. This is the standard that we use for NAVTEX 500 kilohertz. Okay, and you can see, but there's a very similar slide on the other standard. Okay, so it's the basic idea is what is the basic idea? You can see on the left side, you can see all the possible users, imaginable users, and organizations that could use it. Okay, so as Jean-Charles mentioned, we have this maritime safety and security world, but you can use it also for hydrological data, for meteorology. You can use it now combined with ETS, search and rescue. So you can have any type. The characteristic of NAVDAT is that you can use any type of data that you want, okay? And then from a technical point of view, what you would need is, you need a central data NAVDAT server. We call this a NAVDAT server. The NAVDAT server would take any type of data, there's no problem, that are, how to say, defined in a format typically. Let's say for the meteorology, we had this S124 format that Jean-Charles mentioned before. So the server can accept this format, take the data, and then it will encode these data and multiplex the data. So encoding means, okay, we have each data type will be encoded, and then multiplexing means we'll bring all this together in one stream, which is then IP stream. So we come back, the communication between the local server and the transmitting station is IP based, okay? So we need an equipment that will create this IP stream, and this is the role of the NAVDAT server, okay? And then if you look at the right side, yes, this is the transmitting part. In the standard, yeah, obviously we'll have a transmitter and a matching unit with an antenna. This is what we always have for a transmitter. But there are three more elements in the standard, okay? There is a receiver, a monitoring receiver, we have a modulator, and we have a controller. So the receiver in the standard is part of the transmitting station. So it's part of the mandatory part, okay? The controller, what will the controller do? The controller will compare the messages that the receiver has received with the data that we have sent. So, and compare to make sure that we sent the things that we sent were also received. Okay, that everything is in order. And then the modulator, why is it a separate part? The modulator, you could say, is part of the transmitter, but here we are in the world of digital modulation, so it's really a complete different modulation from what we know from NAVTEX, and this is why in the standard they also put it as a different piece. Okay, so this is the standard, and then on the next slide, yeah, thank you. You could see, yeah, how we Nortel, Kenta, how we could realize such a system. Yeah, it's just to avoid misunderstanding. These are not products, but this is just the way we think we would do it in the future. Okay, so on the left side again, you have the NAVDAT server. So the NAVDAT server would be part of the GMDSS server that we have presented in the last webinar. You remember the last webinar you saw, then we have tools for NAVTEX, we have tools for DSC, for voice. Then the NAVDAT tool would be another tool that we will add in our server. And the consoles would be able, with an HTTP interface, to access to the NAVDAT server. And you can configure the server over HTTP. Everything, yes, communicates over IP. This will not change. This is in the standard, and this will also not change on the architecture of the NAVDAT system. Then the receiver side was a little bit different from what you've seen in the first slide. Is the receiver, it can be on a different side. This is at least what we think. It doesn't necessarily to be on the transmitting side. It can even have some advantages to have the receiver not on the same side. Especially you can avoid saturation and things like this. So the receiver, we have currently already MF8 receivers that are available, which we could adapt. Easily adapt. It's, as I told you before, we are specialized in software-defined radio, and with this software-defined radio architecture, it's now much easier to create new receivers on a new modulation scheme. Okay. Then you see, yes, this is for the receiving side. The controller we mentioned before. We are in the world of IP. The controller can be anywhere, but typically it would be also in the GMDSS server, where the GMDSS server or the NAVDAT server would take then the information from the receiving side and from the transmitting side and compare both to make sure that it's the same. And then, yes, on the lower part, you can see the NAVDAT TX side, okay, which is then, yeah. So we would then have in this on the TX side, you would need the modulator, a transmitter, a matching unit, and an antenna. We will have another webinar where we will detail a little bit more this one. But basically, we can say, yes, we will have typically, you would need an antenna, T antenna typically, the best case, as you had already for NAVTEX, but you would need to adapt it because you have larger bandwidth and other things, and maybe also higher power. We'll see this on the next slide. But we will have, yeah, it's a little bit different. So you need to adapt the antennas, and this means you have a little bit different antennas and a little bit different also matching units, okay? For the transmitting part, yes, you know that Nortel is specialized for medium wave transmitters. So for 500 kilohertz, yeah, we, for example, Nortel have already DRM transmitters, so that can easily be adapted. Okay, yeah. Then I think we can go to the next slide. Well, I mentioned that we have different powers and different, yes, on the antennas. So here you can see this is, yeah, a slide that our CTO, Phil Schmidt, has prepared. You can see on this, Jean-Charles also mentioned this, you have different modes in digital modulation. So we have complete different modulation scheme. In NAVDAT, we are in analog, and here we are in digital modulation, okay? So it's a big change. This is a little bit what also happened, you know, in the world of broadcast when they switched from analog television to digital television, to DVB, ATSC, all these standards. So all these standards, if you look at DVB, DAB, DRM, they are all based on digital modulation, and digital modulation means co-FDM modulation. This is a barbarian term for coded orthogonal frequency division multiplex. The characteristic is you have a rectangular spectrum with many subcarriers and different modes. This is what you need to take back is you have different modes, and each mode has, you know, a different robustness. The most robust mode is what you see here. It's a 4QM mode. In the 4QM mode, this is the most robust mode. Yeah, and this is a little bit surprising. If you come from the world of NAVDAT, you see that, okay, it's robust, but we have not so much bit rate. But we can cover, if you say we want to cover 220 nautical miles, this was the assumption we made here, okay? You can cover it with a 3.5 PEP kilowatt transmitter, okay? And if you want, because in the standard as it is today enough, that you can also have a mode with lots of bit rates. For example, Jean-Charles, he mentioned something like a 20 kilobits per second. If you want to go there, then you need, you know, a mode that can transmit a lot of bit rate, but you will have, yeah, less coverage, or you will need more power to have the same coverage. This is what you see in the last line. You have 64 QAM. This is a mode that can transmit a lot of data. So between 19 to 30 kilobits per second. And but in this case, this is really a big difference. You would need a 50 kilowatt PEP transmitter. Okay. So these transmitters, they are, you know, we have these transmitters at Nortel. It's available, but obviously it will change a lot your installation for the Coast Guard. So if you have an installation for 3.5 kilowatt or for 50 kilowatt, it's not exactly the same antenna type, and it's also not exactly the same matching unit. So this is just to explain to you, this is an important slide. I could talk for hours on this slide because it really shows that it's also for the people that are thinking, oh, we want to do NAVDAT. It's not so easy to get the specification right, okay? So I think if you're an organization or Coast Guard is thinking, oh, we want to do NAVDAT, the first question you have to ask yourself, what's the coverage we need? But then there's a second question, how much bitrate you want to transmit? And depending on this, you will have completely different scenarios, as you can see here, okay? So you see on the right side, you know, on the table that we have on the upper part of the slide, this is an estimation that we can that we ran here in our company based on the standard. But on the right side, you can see these are the measurements that have been made in China. Okay, so if you look at the Chinese measurements, so we have 4 QAM, so they got quite a good coverage, but compared to a little bit, it's similar to what you find before. Yeah. We have 220, and here in China they had almost 300 nautical miles in 4 QAM mode. But in 64 QAM mode, they only had 1/3 of the coverage with a 5 kilowatt peak transmitter. We're on a 5 kilowatt transmitter. Okay. So yeah, so there are some measurements. So some measurements exist. We have also estimations. The one thing is sure, compared to NAVDAT, you will need more transmitter power. So we will have another webinar where we will explain to you all these modulation schemes in much more in detail. But yes, the central message here is to say, okay, if you want to do NAVDAT, have in mind which coverage we need, which bit rate you want to transmit. There are big differences then coming out of this on the transmitter power that you would need. Okay, and on the whole installation. Yeah, then we can, I think we can sum up. We can show the next slide. And we can sum up then, yeah, the webinar we had so far. Okay, so NAVDAT is the logical outcome of a long history. Okay, so it's not, yeah, it's new, but you know, we had before we had NAVTEX, and now NAVDAT is a kind of logical follow-up. Okay, we have the ITU standards exist, and in particular, Jean-Charles mentioned we have the performance standard they are out now, and we have also a NAVDAT manual that are out now. Okay, they're not, how to say it, they need to be completed, and they are currently completed, these standards. Okay. It's important to get that NAVDAT can broadcast any type of data, and yeah, we gave the example of the hydrological data with the S124 mode. There are different broadcast modes, so you can have general, selective, and dedicated. Okay, so this is what Jean-Charles explained. We are in the world of digital modulation, which is a big change compared to analog modulation. And linked to this, we can have single frequency networks, which is not possible in NAVTEX, because NAVTEX you would have interference. But if you're in digital modulation, then the big advantage is, you know, if you stay within the guard interval, you can have even higher, even better coverage with on one frequency. This is one of the big advantages we have here with the NAVDAT system. So the field test has been done. We have shown this. So coverage and power estimations are available. So we have now a good idea what is really, what powers and what equipment you would need to do NAVDAT. And now I hand it over to John White to conclude the webinar.
Thank you, Herman, and thank you, Jean-Charles. There's quite a few questions, and we'll get to those in just a moment, but I just wanted to take a moment to talk about where can you learn more, what might be the next steps. So as Herman mentioned, we are planning a future webinar. We'll be setting the date on that shortly. You can always stay informed by joining our newsletter at Nautel Nav. We'll be showing up at Europort and at Marine Tech in China in the coming months. If you have a curiosity to maybe have a discussion about assessing your current infrastructure and how it might be transitioned to NAVDAT, we'd certainly be glad to entertain those discussions, or possibly you're thinking of implementing a trial to learn more. So all these things are pieces that we would be glad to discuss with you. If you could move to the next slide, we'll start, just remind people how to enter questions. So in the control bar, just pop down below and you can enter your questions, and we'll see if we can answer a few of those today. We are probably getting towards the top of our time, so I'll jump right in, and there are some excellent questions here. So first off, this is a great question. Is NAVDAT a replacement for NAVTEX?
Oh, this is Jean-Charles. We can answer this one. Because
So once again, the question is NAVDAT a replacement for NAVTEX?
But of course, ITU, the International Telecommunication Union, prepare all radio communication system for the maritime world. That means for the International Maritime Organization. I'm a French representative, so we participate to ITU and to IMO. IMO want digital. And to be honest, I had participate to the Worldwide Navigation Warning Committee 2 weeks ago. They all want digital information, but for the time being, there is no process. So the problem is the willingness of government, that's all. And so we have to go forward. And of course, for French, we are convinced, China also, Ireland also is convinced, and I think more and more, because we want to have digital information on board ship, that's all. The way we have to produce will depend on an international coordination. So you can imagine it's not for tomorrow, but just after tomorrow we are ready. That's all.
Yes, from a practical point of view, Jean-Charles, how do you see it? Because I think most probably you will have NAVTEX and NAVDAT, they will coexist for many years, I guess. I think this was the background of the question.
Yeah, but
completely replace, they will coexist, and then probably NAVDAT will take over, because it's no need anymore for NAVTEX.
But that's why it is interesting to see that with a NAVDAT station, you can continue to broadcast NAVTEX.
Yes.
That's why it's smooth integration with the future, because of course you will still have many ships, and when I speak of ships, I'm including all ships, because this is a global requirement from SOLAS to government, not only for SOLAS ship, but for all ships. So the challenge is there. It's not only SOLAS ship, but fishing vessel, yachts to receive information. And so that's why we push at the IMO performance standard requirement for receiver on board, because the technology is ready. So of course, and anyway, there is a situation of saturation with NAVTEX. This is the situation that has been noticed everywhere in the world, because there is a need for more and more information, and the telex system with NAVTEX is totally saturated. As soon as there is one NAVTEX down, it is supposed to be taken over by the next station, but they have not even the capacity to broadcast their own information. So it's like a domino collapsing as soon as one is not working. So that's why it's a total new paradigm we want to go. If I have to give you an answer, I will give you the French answer. Yes, NAVDAT is the future of NAVTEX.
Yeah.
So I have another excellent question here. Will ships have the possibility to transmit NAVDAT messages to other ships or back to shore-based stations?
This is a very good question. So NAVDAT is just a broadcasting system, okay? But the idea now is to introduce digital information everywhere. And we, as I explained, with the modernization of GMDSS, we review all text related to GMDSS, including the VHF, MF, HF performance standards. So far, I follow the discussion. Germany and Japan introduce very smartly, because it doesn't make noise. And very smartly, they combine MF and HF performance standard, because you all know this is the same device at the end of the day. And they introduce smartly automatic communication system used based on the DSC, but that can make easier the connection from ship to ship and ship to shore. But also the step after is ready at the ITU. After the World Radio Conference of 2012, the Appendix 17 of the radio regulation dealing with all the HF, and we have a large amount of HF band, it has been prepared to be rearranged, and IMO decided to discontinue in the modernized GMDSS. Maybe too soon, but this is a decision. There is no more communication on narrowband direct printing. But that means this frequency will be used later for data transmission. And so far I know, the data transmission are already used for a long time by the Navy in the world. So there is nothing new. It seems that we are making a new sexy way of Marconi system, in a way, just by introducing digital information. And of course, that would be nice to make a point-to-point. And so far, I have been informed in Korea, the ministry in charge of fishery has implemented a kind of NAVDAT with the possibility from fishing vessel to send back some information, but very basic, because the power is different. So of course, this is the next step. Point-to-point digital communication, even the voice digital, even the files can be transmitted, etc. This is the way. And again, the philosophy of GMDSS will be still the same. but we just have modernized, and we can be totally independent from the satellite in case of any problem.
Very good.
Okay, I can give a technical, as the standard is written today, I would say it's not, you don't have ship-to-ship communication. It's really from shore to ship in broadcast mode. This is how it's written today. But yes, it's good to have Jean-Charles with us, that he explains you how the way of thinking, how it will go further. Thank you very much.
Sure. And I'll just let the audience know that the slides and presentation that you're seeing today, the video will be archived and it'll be available on YouTube and also on the Not Till Nav Kenta website. There are several questions about what will be the implications for the shipboard equipment. Will NAVDAT receivers be mandated?
I can answer. Now the philosophy with the new amendments of SOLAS, there is no quotation in the convention about any maritime safety information system. Member states agree to make a list of systems agreed by the organization. So this list could be updated. For the time being, the first system still on the row is HF narrowband direct printing, because it's still in force. IMO doesn't terminated this system. Be aware there is only 10 HF narrowband direct printing in the world transmitting. In comparison to the HF facsimile, there are 30 station broadcasting HF facsimile. So the other one system for maritime safety information are enhanced group call through Inmarsat and now Iridium. And then there is NAVTEX. So this that means a ship at sea has to be fitted with the appropriate system to receive maritime safety information. And as I say, some information broadcast on NAVTEX are not rebroadcast on satellite. So they have to adapt, and that's why there is a GMDSS master plan that all countries have to inform the establishment of GMDSS infrastructure in order ships will know where to navigate with which system to receive maritime safety information. So we can imagine little by little introduction of NAVDAT station. That was the case of NAVTEX, was introduced before 1999. It was introduced in the 90s, so little by little, and that's why it is used also by yachtmen and fishermen.
Thank you. So a broad question here, and I'll just mention, if we don't have time to get to all the questions, we'll try to respond by email to the questions that have come in. There's the broad question that references that we mentioned that the integration of NAVDAT for a smooth integration, but the questioner asks, we must admit that it requires quite a heavy investments in antenna, high power transmitters. If the main argument is more data and not SAR MSI, would SATCOM, satellite communications, not take over that approach for VDES and MSI over satellite, safety cast, etc.?
It's a wide question. It's very open. So that's why you you have to follow the discussion at the IMO. So there are different systems. GMDSS is a combination of system again. It's not you don't have to differentiate satellite and terrestrial. They are all radio communication. So what we are presenting with the NAVDAT is a simple system just to broadcast information that can be used for maritime safety information and SAR. So VDES is another technology with two branches. One is terrestrial, and the coverage of the VDES is approximately the same. as VHF because this is a VHF band. So I can tell you straight away that for IMO, ISO, and WMO, this is not their problem because there are a lot of difficulty to coordinate worldwide navigation warning service up to the coastal area. So VHF coverage is considered internationally as a local area, and this is up to all countries to manage. Now, the satellite component of VDS, okay, welcome. But be aware, I am in charge to coordinate the revision of the resolution 1001 of the 25th Assembly related to the criteria of mobile satellite service. And I can tell you, this is a nightmare. It's not a problem for the seafarer because all is transparent. But there is a political problem, much more wider than VDS, NAVDAT, or whatever you want, is for many years, 18 countries, including France, United States, Canada, are only in charge for all the shipping and navigation transmission because they are a private company in Marsat and Iridium. Now everybody wake up. Suddenly, this is a private company. We have to pay. And that are political consideration, but on a technical way, we have to combine also the coordination of orbit and frequency at the ITU. So IMO can do nothing without the coordination of orbital and satellite. And to be honest, I am a bit frightened to see so many satellites in the air since 1957, the first Sputnik going around the world. And we are back to the ground on the surface of the sea. I am talking about safety at sea. So keep in mind the basic requirement of GMDSS still available. We need two independent systems to send a distress. And in my view, we need also two independent systems to broadcast maritime safety information. So think about the HF facsimile is still in force, 30 stations in the world with old technology from the 1910. It's a French technology, the belinograph. So what I mean in this presentation is to say, okay, we can modernize, but we have to take into account coordination of frequency at ITU, many other political considerations, and also the feasibility of technology on board all ships, including fishing vessels, where are the most focused to SAR operation, in my opinion.
Very good. That was certainly an excellent question and a great answer, Jean-Charles. Going from broad to a very more technical question, and maybe this will be the last question we'll take to give people a chance to get back to their day. And once again, we will try to provide responses. So the question is, how do the transmitter and the receiver, how do they synchronize about the different modes? So 4 QAM, 16 QAM, 64 QAM. How does that happen?
Yeah, the way it works is like this. So first of all, yes, we need in all the transmitters, by the way, you saw this in the slide, you need GPS signal. So if you have a digital modulation, for NAVDAT, you definitely need to synchronize perfectly your transmitter. This is the first step. And then for the receiver, well, the receiver will know that there will be a change in the mode. Okay, so you will have a special, how to say, signalization channel that will warn the receiver. Okay, that will transmit to the receiver. Okay, this is the channel we are now in, and if it changes, yeah, it will, you know, give first on a standard channel that's always the same modulation. Okay, say okay, you need to change, and then the modulation for the main datas will change, and the receiver will know it like this. Okay, and will synchronize itself like this. But it's true, you need to tell the receiver somehow that we have a change from for example, from Q4 QM to 16 QM. It's a good question.
Yeah.
Hermann, if I may, in general, all this digital transmission system, it is like AIS, VDES are using and NAVDAT use OFDM, orthogonal frequency demodulation system. So, and this is, as you explained also, the same technology you have with digital TV.
Yes.
So it's a very common use. Of course, it's a kind of magic because of this technology used in the different system I quoted. So after you have the same problem of modulation with NAVDAT, NAVDAT, AIS on your TV.
It's I agree. It's not something that is completely new. So this digital modulation schemes are used in many technologies. So it's field proven. We are not, you know, it's not. So this is why NAVDAT is something that we are sure it will work. There's no doubt about this. And why the trials were so successful also.
Very good. If we could move to the next slide. We've had some excellent questions. I hope that this content has been very helpful for you today. I'd like to thank Captain Cornilloou. Thank you very much for joining us today. You really added to the discussion and awareness and information that we provided. Thank you, Hermann, and thank you to all of you that have joined us today. We look forward to seeing you again in future webinars, and please feel free to reach out to Hermann and his team if you have any questions or need any assistance as we contemplate the move towards NAVDAT. Thank you very much, and you have a great day.
Thank you.